Well, hello to everyone. I'm Antoni, and this is my project for application of Matlab-Octave to thermal engineering problems. A subject I'm making a TCAT, and my project is Matlab interfacing with an FPGA board. Well, what I'll explain here in this presentation is mainly what is an FPGA, what's the serial interface and how it works, why I use an Arduino, what's the experiment I make, and how I can tell the code is correct. To start with, the FPGA, I will explain that it's a programmable board, so you can design the circuit inside. You can put logical doors, you can put modules, connect wires, make registers, so the maximum performance is guaranteed for specific tasks. And I programmed the whole Field-programmable machine that amounts to about 1000 lines of code. So I could perform the task. I tried to do an experiment to communicate MATLAB and FPGA board. The serial interface itself is UART, which is a really easy standard to follow. So I can communicate really easy the FPGA board with the PC, and I can use a USB cable, which is a different protocol, but the same FPGA has a chip that does automatically the conversion from UART to USB. I used an Arduino so I could test if the FPGA board was working as expected by providing input at a high frequency. And I have to make a comment about Arduino, it's that it's really the most effective way to test other circuits, as you can really program really fast a small test and put it easily with other boards. The experiment itself is basically the FPGA programmed to be a pulse counter that counts for a number of seconds determined by MATLAB using the serial interface. And when the number of seconds that MATLAB has asked to be counted get to an end, the board returns the result to MATLAB as an integer, so you can see if it was working or it wasn't. And the pulse generator is basically the Arduino. And now I will explain the experiment itself. You can see here a proto board, an FPGA board, that is the red one, and the Arduino board, which is the blue one, as all Arduinos, or most of them. And you can see a little zero here, that it means that the FPGA board is waiting for input. When I ask my MATLAB to start counting, it will turn into 7, and when it has stopped counting, it will turn back to 0, so it's waiting for new orders. You can see the LED of the Arduino, which is blinking at a really fast speed, so our naked eye can see it. And well, you can see now the experiment how it works. First I will show the Arduino code, which is really easy, and it makes pulses at 30 microseconds, sorry. Then the MATLAB code, which is small but not really easy, as it uses special codes and functions not usually used by most of people. And when you see is how it starts to work and how the 7 appears in the FPGA board, in the proto board, sorry. You can see 7, and when it stops counting, it will turn back into 0, you see. And we have the result in the MATLAB console, which is 166,133 pulses in the 5 seconds we have counted. And now for the code correctness, and looking at the figures obtained in the test, I can compare the expected output with the real one. Well, Arduino was making a pulse every 30 microseconds, or so we thought, so after 5 seconds of counting, 166,667 pulses were expected. The number obtained by FPGA was 166,933, so there is an offset of about 266 pulses, or an error of 0.16%. Well, as the result is the same no matter how many times the experiment is made, yeah, I repeated it an awful lot of times, we can assume the FPGA is working as expected, and so is Arduino. So the problem is that the clocks inside both Arduino and FPGA don't seem to really know what the real second is, so they count something that is not the same, and one counts some pulses and another one counts something else. Well, that's it. Thank you for watching. If you want to see the code, just ask me. And if you have any questions, please just put in the comments, or ask me from my email if you're in the class. Thank you very much.